So you might be wondering, why are we using Alpine Linux and why not Ubuntu or CentOS? Because Alpine, nobody has heard much about it, but let me tell you something from my experience. So first and foremost, I was always using CentOS because that's really a server you use. But throughout my experience running containers on Kubernetes, the fact is that when Google is running their own servers, that is running Kubernetes. So essentially, Google is running their server, and their server is running Kubernetes. And then those Kubernetes are running your server. Their server is built on CentOS. This is why when you're deploying CentOS on the Kubernetes, it's not going to work nicely. There's going to be some conflicts. And moreover, it's not a container optimized package. Let's now examine Ubuntu. Ubuntu is great. It's great as a server, but Ubuntu is more like a software that you use for your computer, and its weight is around 200 megabytes, whereas Alpine's weight is a couple of megabytes. This is why Alpine is more server optimized. It doesn't have any extra features that it doesn't need. And what it means, if there are more features, there are more ways to access your server. There are more vulnerabilities. Therefore, it's more dangerous. And this is why I'm suggesting to use Alpine. It's, again, optimized. It doesn't have too many packages. This is why the chance that your server could be hacked or something is really small. And those are the reasons why I'm choosing Alpine. And more besides that, the performance is great. I'm running multiple servers, multiple Docker containers on Alpine, and I'm very satisfied with its performance. This is why in these tutorials I'm going to be using only Alpine containers. I'm going to talk with you about using Google Cloud. I really suggest using Google Cloud because it's very optimized, integratable, and scalable. So let's begin by going to cloud.google.com. Let's proceed to console. And this is where we're going to set up our demo account. So here's, we're going to agree with the terms. So see, they're offering trial with $300. You can go ahead and activate it. This is going to allow us to use their features. So here we need to sign up. Whenever you have set up the Google Cloud account, you will see the following screen. So here, essentially the products on the left, these are all products that we can use. Let's scroll down to compute, and let's select Kubernetes engine. Let's select it. Let's pin it. Now we need to find container registry. Let's look out and add it in, please. So here it is, container registry. At this point, we will use container registry. We want to push our image to Google Cloud. So Google Cloud is gonna be aware of existence of your image. Let's select it here and let's press enable. So here you go, the API was enabled. It recommends you multiple tutorials here. I'm gonna close it out. So really what we care about here are the images. So now, once we have set up our account on Google Cloud, we will want to be able to push an image to this container registry. Let's do the following. First of all, press on my first project and please copy this ID. Okay, I'm usually then copying it into the screen and copying it in order that it won't copy or copy the HTML, CSS, all that. I just want the clean text value. Okay, so and now let's go back to our PHP store or any other ID that you're using, and let's type in the following code. So step number one, you have to authenticate. Google Cloud with your local terminal. And we can do it the following. Just say Google Cloud, authenticate, auth, login, Vadim at your email, okay? And now it's gonna give me an option to authenticate. I'm just selecting my email, allow, perfect. Now I have authenticated. Very good. So now we're gonna use this project ID that you copied, and we will say the following: Google Cloud config set project this. So you see it updated the property, the project ID. And now we can do the following. We will say, first of all, we have to build an image. So this is Docker build, hello world. So we have created our images. We can verify it by typing Docker images. The image is here. And now we want to push our image to Google Cloud Container Registry. And we can do it the following way. And first of all, we will say Docker tag hello world. And we will use this us.gcr.io. Here you gotta put your project ID. So in my case, it is inner catfish and then some ID. And I'm gonna say hello world because that's the name of an image, and 001. So here I'm defining a version. You can keep it as 001, and in production case scenario it's random, and I'm gonna show you that as well. So let's tag it in, and now we want to push our image to container registry. Let's do the following. Let's just repeat docker push, and let's just copy this part, and here you go. It's currently pushing your image to Google Cloud Container Registry. So as you see, it's pushing it on the multiple layers, and it has finished on pushing the package, our image to Google Cloud Container Registry. You see it says here the ID number, the size, and we can go back here. We can just hit a refresh, and you will see that our image is here. So now here you can close this out, and you can examine that your image that's hosted on gcr.io, it's a private image. You can open it, and you will see the tags, because you see here 001, you can push a 002, and let's do that. Let's just tag in another version of your image, 002. We can push it out, and you're gonna notice the second time you pushed it, really nothing changed. This is why the Google was able to push it so quickly. And you see it's saying that we have two versions of the same image. If you were to change something here, let's say add some note by saying test here, and you would build your image. And once the image is built, we're gonna make a third version. We'll tag it as 003, and we're gonna push it. And as you see, the Google is pushing more stuff right now. So now we have pushed our third version. Let's go back to Cloud Registry. Let's open our image, and you're gonna see that there's another name for this container, for this image, and it has a third version, and it was pushed just now. So every single time you're gonna push a new image, or your system is gonna push another image, you're gonna see the history. So for example, if you need to push a backup, you need to use an image that was created yesterday because today is buggy. You can just copy the name and use that image. In this chapter, I'm gonna tell you more about Kubernetes. I'm gonna explain you how they work, what is workload, what is cluster, how do we make a new workload, how we expose the workload to an outside environment, how we deploy our Docker image on a Kubernetes. What is cluster, what is workload, how do we deploy a workload to the cluster, how do we deploy a Docker image on a cluster, how we expose it to outside environment, what are load balancers, and so much more. In short, after this chapter, you will know exactly what is Kubernetes, and you will have a full understanding how to deploy Docker image on a Kubernetes. Let's continue. So let's ensure that we are able to access Kubernetes on our Google Cloud platform. So please find Kubernetes engine. If you did not pin it here, just look at, do Control F, look for Kubernetes engine, and just press on them. So here Google will ask you to enable this API. So just hit enable. It's gonna take like half a minute to enable it, and then you will see everything that you need to see in order to work with Kubernetes on Google Cloud. In essence, the interface is different on Google Cloud, on AWS, on Azure, but the concept and the way it works is the same because Kubernetes don't change. Even if you go onto their website right here, Kubernetes.io, you would see that they are explaining you everything you need to know about the Kubernetes, documentation, and so on. And there's really no attachment to Google Cloud, Azure, or AWS. It's a standalone product. Great, so Google has enabled this API and we should be able to see this screen. Let me explain you what are Kubernetes clusters. That's the main concept of Kubernetes. Imagine how you were doing it before. Before you would create VM instance, you would tell that you need 5 CPUs, 20 gigabytes of memory, and you would tell that you need that this VM instance needs to run on specific Linux. However, here it's a bit different. You are telling Kubernetes that you need cluster that's deployed in a specific zone, that you need 5 gigabytes of memory and 2 CPUs, for example. And then on this cluster, you can run all your applications, whether those are front-end applications, APIs, backends, and so on. So let's dig into it. So on this screen, we can see our clusters under our GCP project. So here I'm gonna hit create, and Google gives us 2 options. So whether Google Kubernetes Engine Standard or Google Kubernetes Engine Autopilot. Let me explain you the difference between these two. So in standard version, you're able to tell it how many CPUs and how much memory you need to dedicate to this cluster, and it will dedicate it, and it won't be changed. And we will talk about auto scaling, all that, because even standard option, it allows auto scaling. However, it's much more different with autopilot. With autopilot, you don't need to define CPUs, you don't need to define memories. Google is going to decide how big node is supposed to be, and Google will create it for you. And as far as cost optimizations, performance, scalability, my best advice would be to go with GQE Autopilot, because it's much better when system algorithm, in this case Google's algorithm, is able to track how much CPU you need, how much memory you need, how many servers you have, and then it's going to deploy the proper nodes on your behalf. So you don't need to worry about it. I need to ensure that you know a clear difference between these two. So let me press configure on a standard, and then we're going to go to the autopilot, and we will deploy autopilot. So when we are creating a standard, let's take a look what options we have. So here we can set up a name, cluster 1, that's fine. We can select zonal or regional. So this is the difference. When you select a zonal, you can specify in which zone you would like it to be deployed. And there's one big issue here, because if one zone goes down, that's it. It won't be able to support another zone, and all your applications are going to be inaccessible. They won't be working, because if Google zone goes out, there's absolutely nothing that you can do. However, this is what Google's offering. It offers you to select a regional cluster. So this is what it means. You're just selecting a region. You're not selecting a zone. So let's say I'm selecting US East 1, and it tells me that there's 3 zones on US East 1. So what this means, if in case that Google's zone is going to go down for whatever reason, because these things happen, they can happen extremely rarely, but they do happen, unfortunately. So imagine one zone goes down and you still have clusters in 2 other zones. So you are safe because all your traffic from this one zone is going to be redirected to another zone. And that's very beneficial. And my advice, whenever you're choosing a region, take a look which region you need to choose, because it all depends on where your users are at. And let's say in my case, I'm located in New York, so I know that this is going to be US East 1, but let's say you don't know which zone to choose. So there's a great tool for that. Let's go onto Google and let's just Google this GC ping. Here you go, measure latency to Google Cloud regions. Let's just open it. And as you see, it's making connection to different regions of Google Cloud, and that's giving me latency. The green one, that's the suggestion of the zone that I should be using. As you see here, there are 2 favorites so far, US East 4, which is Virginia, South Carolina. So if you look at the maps, right, go on to maps, and you see that here's New York, and we have South Carolina here, or you have I think North Virginia, US East 4, North Virginia. So obviously that the ping, the latency is gonna be less from North Virginia than from South Carolina. So in this case, we would choose US East 4, Northern Virginia. Another option is Montreal, but I'm gonna go with North Virginia because it has the least amount of latency. And look, deploying Kubernetes and deploying online cloud services, it's all about performance. So let's go ahead and choose US East 4 in my case. In your case, look which one is the closest to you and select that option. Alright, it allows me to specify default node locations, and I'm not gonna do it in this case. And here we have 2 options. So static version, or I can choose one version and it's gonna stick to it, or release version. I would suggest to go with the release version because you want to stay up to date. Let me explain you why. Because Kubernetes, as any other technology, it's a technology that evolves every day, and each technology has bugs, and those bugs get fixed every single day. So there was a day where Kubernetes released as some security patch because somebody found some way to hack it, and Google sent an email to everybody right away, hey guys, update your clusters right away. And this is why it's very important to select a channel. You can't just select static version because it has its own drawbacks as you go. So I can select either stable, regular, or rapid channel, right? I would suggest to go with the regular channel because look, the latest version is 1 to 1.6 here. If you look at the rapid channel, it's 1.22. What's the difference? The difference is the following, that in rapid channel, whenever they release new updates, you can get access to them faster. However, if any update has some bug or sort of that, there's no guarantee it's not going to crash. Therefore, I would suggest you to go with regular channel. Look, it's just 1.21, Rapid has 1.22. It's not a bad difference. Therefore, you're more secure with choosing regular channel. These are cluster basics. Let's examine node pool, and let me explain you what is node pool. Because in this cluster, we just told Google the right configuration that we need here, but we still need to choose CPU and memory. And this is what we would do in nodes. So you see here, you're choosing image type. I suggest to go with the most basic one. This is special container optimized OS that Google is running on. And here you can choose machine type, such as standard, high memory, high CPU. Really depends on what you need. You can select SSD disks and do a lot of different things here. And that allows you to select some security settings, metadata, and then you can go on to automation, networking, enable VPC native traffic. Yes, keep that enabled. So everything that's here, you really don't need to change anything. It all looks good because it's based on their best recommendation for yourself. So let's go back to cluster basics. So this is really how we would set up a regular cluster. However, because Google has released this incredible update on Autopilot cluster, I'm gonna go back to this page. I'm gonna hit create again, and I'm gonna choose Autopilot version. So let's press configure, and as you see, the configuration is much more simpler. But in order to use whatever simple, it's always good to know what's behind it. And let's just keep this name Autopilot Cluster 1. Let's select the region that we found out is the best, US East 4. Let's keep it as public cluster. Let's select network options. They look fine. Advanced options, everything looks fine here as well. So as you see, we just keep the same name, change the region, and hit create. So now the Google is going to create your cluster. And the beauty of this cluster, whether you're deploying one application that's going to use 2 CPUs and 4 gigabytes of memory, it can still use the same cluster. And if you're deploying an application that needs 30 CPUs and 100 gigabytes of memory, it still is able to utilize the same cluster. So as you see here, it created your cluster, and the status says that it's still being created, because remember, whatever we see just the cluster, but behind it there's so many things going on. There's separate metric services, separate Kubernetes services that are running, monitoring performance, making sure that every single function of Kubernetes is working. But that's already behind the scenes. But as we need to know that this Autopilot cluster is going to do all magic we need for us. And yeah, we have successfully deployed our cluster. Let's just wait for it to finish. Great, so we see that this green check mark here, so it means that Autopilot cluster has finished setting up and it should be good to be used. Let's explore the next part. Those are workloads. Workloads is also a very important concept, because those are your applications. Imagine how we created a Docker container. We were able to run it. So whenever we were running it locally on your computer. However, now we will be running it on a Kubernetes engine. And on Kubernetes engine, they call it workloads, because workload equals your application. So if you have API, you have front-end instances, you have back-end servers, all those are called workloads in Kubernetes world. So you would be deploying and creating a separate workload for each of your applications. So let's continue to workloads page right here. As you see here, it says deploy a containerized application. Let's deploy it. So I'm gonna hit deploy, and in this case it offers to use existing container image. So here it's proposing us to use Nginx latest, and let's do that. Let's just select it, hit press done. Let's continue, and now we have to give a name to our workload. We will call it hello world. All right, or let's actually call it front end, because it's gonna be less confusing. So we will call it front end, and all these options look fine. Cluster, just select your cluster here and hit deploy, and now it's going to deploy your front end on your Autopilot cluster. As you see, it's using existing cluster, creating deployment, and then it's creating pods. So let me explain you what are pods, and let's just wait for it to finish. Great, so Google has finished setting up your workload. Let's examine whatever we see right now. So sparse documentation, we can close it out for now, and this is what we are seeing. You're seeing pod errors unschedulable. So let me explain you first of all what are pods. Number one, frontend, that's your workload, that's your application, that's the container that you deployed on a Kubernetes. Imagine that you would need to have 3 VM instances of the same application. So the concept is very similar, that frontend is your application, and here it's deploying 3 instances of your application. In Kubernetes world, they wouldn't call them instances, they would call them pods. So managed pods. So it means you see frontend and then there's a special ID hash, and it has created 3 pods, 3 instances for your server that you deployed. So let's hit refresh, and you see it turn from red to green. And let's take a look. So see, it's running 3 pods, 1, 2, 3, and it gives us statistics for CPU, memory usage, disk usage, and there is so much more to explore here. So now let's deploy your Hello World container image on Kubernetes. So first of all, let's open container registry images section. And let's take a look here. So here we have our Hello World. I see that a little misspelling, so let me just correct it. So here I'm gonna go back to our project. I'm gonna change it up right here. Hello World. Set it up as a first version, and I'm just gonna copy this here. And I'm gonna say docker push. Perfect. So I should be able to refresh this page now, and I will see Hello World image. So let me just copy this here, and let me go back to frontend, and now we will break down the YAML file, how the YAML file works, what that is, and how we can deploy our image on a Kubernetes workload. So let's press edit, and this will be our YAML file. It can look very confusing at first, but let me make it very simple for you. So YAML file, that is a configuration. That is a configuration for the workload, and Kubernetes needs to know that configuration because Kubernetes needs to know what images to run, what ports are exposed, what are memory and CPU and storage prerequisites. It needs to know whether application is running or there are some errors with it. And there are so many more things you can implement in this workload. But let's start from simple things first. So here, whenever you're exploring this YAML file, as you see here, there's a lot of things. But let's keep it simple. Don't bother with these things. These are automatically created by Google Cloud. Start checking the code really from this line which says spec, and these ones, no worries about them. Let's take a look here, and metadata. So name of the app is frontend. You can change this name here as you go, but this is what we care about. This is the containers, because in this workload we are running containers, and you're not limited to running one container. You can run multiple containers. And let me make you an example. So let's say you're deploying a backend instance, and you need to make a special proxy, special tunnel between this workload and your database, where you're authenticating all the requests. So you would be able to put a separate and additional image, which is going to be called proxy. But in this case, let's explore what we are seeing here. So look, spec containers. So this is where a list of containers starts. And the syntax is very similar to multiple languages that you might know. And you have to ensure that that the lining is appropriate, because as you see here, the way the lines tell us that each container starts with this minus sign, and then you have image, and this is where the image comes into the play. So in this case, this is Nginx latest. Google's pulling this image from its own container repository, but essentially it's a Docker hub that's pulling it from. Image pull policy, always name, this is Nginx 1, and the resources. Very important part, resources. Let's say, in this case, Google knows that Nginx will need 500 megabytes and 2 gigabytes. In reality, it needs less. They're just setting these as default values. And you might ask, what is the difference between limits and requests? Let me explain it. So limits, that's absolute maximum amount of CPU, ephemeral storage, and memory that the container can use. Otherwise, it's going to become unresponsive, it won't work, and eventually it will crash, and Google is going to kill it and retry to create it again multiple times, and it's not going to look nice. This is why managing proper resource requests is very important. So in this case, they're setting it up for 500 M. So let me explain you what is M. So here, one CPU core could be written like this, either 1, or you could say 1000 M. So one CPU core has 1000 M units. In this case, we just need half a core. We are setting it for 500. Memory, we are keeping it at 2 gigabytes. And these are the requests. These are absolute minimum requests that this workload will meet. So in this case, it's 500, but you could even keep it at a little bit lower. So let's say 400 M. I'm going to change it up, and I'm going to change this as well. So how do we change gigabytes to megabytes? Let me show you. So 2 gigabytes has 2000 megabytes. And in this case, we want to change it to 1500 megabytes. This is how we would do. We would change it to the following. So we're going to say 1500 MI. So MI, those are megabyte units, all right? And here, security context. So this is the default security context provided to us by Google. From my experience, there are many packages, many tutorials that will ask you to change it, to run it as root, and many more things. But from my experience, keep them as is. If your container or your Docker file requires you to use security context to grant more privileges or run as root, that's a bad practice. It means that your container is not built right. Let me just make you an example. Let's say there's some cron library that needs access to root. No, you can always do it differently. You can always find ways to bypass. This is why I'm not suggesting to include anything here, at least for purposes that I have used, such as crazy important API services, robots, and so on. I've never had a need to use it, unless it was a bad practice. And I can tell you a story from my experience where I once put something like run as root, and that was CentOS image, and it was getting access to the cluster, and it was using resources of cluster, and there was so many things going on there. It was taking resources for cluster. Cluster didn't have resources for its own pods. It didn't know what's going on. This is why it was crashing, and when it finally rebooted itself and came back to normal, it was crashing again and again. And I was on numerous calls with Google to find the best solution, what's going on. In the end, I did find a solution on my own, and it was not to use CentOS, to use all by Linux, because it's very container optimized. It doesn't require any special security context. This is why I really want you to understand why we're not putting anything in security context. And let's continue. So termination message and termination policy. So these are the default values. We will keep them here. And at this point, after watching this video, you need to understand what each of these things do. You don't need to know how to write them by heart, because you're always going to make mistakes, and that's fine. This is why I would suggest you to make a cheat sheet or some notes where you can just copy it in and leave it. So when you're deploying your next and next and next workload, you will know what to put there. Or alternatively, you can go back to this project, your test project, and just copy the things that you did. So let's just save it. After you save it, so you see the resource could not be updated because of a conflict with another pending update. So in this case, it's not a production, so I'm just going to press force update. And as you see, we have one instance that's running and one that's currently unschedulable. So let's wait for it to become active. Alternatively, let's deploy our own image to this cluster. Let's hit a rolling update right here, and I'm going to explain you what each of these buttons does, because they do require a separate video, because each of these functions is phenomenal and it really helps you in your developer world. This is why we'll have a different video for each of those, but for now let's hit a rolling update. And here you see it says image of nginx1. I want you to go back to repositories, select hello world, and I would like you to copy this image, and now we need to find a way to properly paste a way to this image. So let's do that. So Google has a really nice button here. You press these three dots, you press on deploy to GQE, and here it allows you to create deployment right away. So in this case, we already have a deployment. So you just copy this path to this image, go back to workloads, or actually you can go back here, just restart it, and you see this is already green. So it has updated, it is updated. So here we're gonna hit actions, I'm gonna press rolling update, and we're gonna change this nginx latest to our own image. So press update. And so now this is what's happening. We have deployed our own image on a workload. Congratulations. But now let me show you how you could do it differently, because this is just one of the ways you can hit rolling update and update path to your image, or if you're deploying new versions, you just hit 02, 03, and so on. But in this case, you could also, as you see it's crashing, we'll explore the crash shortly, but you could go to edit, and right here you could change the name and you can change the image. So let me just change the name to hello world, just so it's consistent. It's always good to keep names consistent, because then you won't make some spelling mistakes, because if you keep the same name there, and there in different places, it's gonna be good, and you will avoid using different names, which is gonna lead to less amount of bugs you could encounter. So let's hit save here as well, and let's explore the issue. Let me explain you what was the problem and why the workloads were failing. So the issue is that my computer is running on M1 chip, and it's different architecture. However, the servers, they're running on different architecture. Therefore, whenever you are building an image locally and you want to deploy it on Kubernetes, which is really not the case, because usually we're auto building, so I'm going to show you that later, but whenever you're building it locally, you have to specify for which platform you're building an image. So in this case, let's build an image with the right architecture. So we're going to say docker build, and now I'm going to specify a platform. So the platform is going to be AMD 64, and let's specify the name, hello world, and dot. So here you go. I'm going to build an image, and the build has completed. And now we're going to push it online. So let me specify, I'm going to tag it as a version 4, and I'm going to push this version 4. And that's it, it has deployed. So in this case, I'm going to hit refresh. I'm going to push rolling update. And now it's gonna kill this old pod, and it's gonna create the new pod. So let's wait for it to happen. However, what we can do in order to ensure that this build happens faster, you can go to actions, you can press auto scale, and here you can either specify minimum pods. Let's say that we want to have minimum to 2 pods, and let's update it. And then in the rolling update, here we have a couple of options. So you see update workload pods to a new application version. So minimum seconds ready. That's one option. However, this is what we really care about. Maximum surge, maximum unavailable. So imagine you have 10 servers, and whenever system is building, it's not gonna kill all 10 servers, put all 10 at the same time. The way it works, it's gonna kill 25%, but if you look at this configuration on 25%, so it's gonna kill 25% of the pods and replace them with new pods. Then it's going to kill another 25%, another quarter, and it's going to build another quarter of new servers. And little by little, it's going to push the new version out. So in this case right now, because we're running on our development, we want these updates to happen quicker. We don't want to wait. So I'm going to change it to 70%. And this will ensure that the build is happening much faster than you observed it before. So let's see. Right here, it has already... So here you go, you have two pods, and congratulations. So this pod shows it's green, and let's continue with the next steps. After we have successfully deployed image on this front-end workload, we will access it and monitor it. Please open terminal, and first of all, we need to authenticate ourselves with the cluster. So first and foremost, make sure that you have authenticated onto Google Cloud. If you did not, please do it now. So I'm going to say Google Cloud auth login Vadim at ctomentorship.com. I'm going to set my project ID, which is going to be gcloud config set project and your project ID. You can get project ID right here. And now the most important part, we're going to say gcloud config, actually gcloud container clusters get credentials. And now we have to copy the name of our cluster, which is autopilot cluster 1, and we have to specify a zone right here. So we're going to say US East 4. So here we go, fetching cluster endpoint and authentication data, and the entry was generated. So now we have a direct access to our workloads. So please copy one of your pods, because your workload has 2 pods, and we can connect only to one of them at a time. So copy the first one, and now let's type this code. kubectl, this is one of the Google Cloud Kubernetes command. We're gonna say exets, which is execute. Now we're gonna say ti, this is needed command in order to access it. Now copy paste the pod ID and type in sh. So now it's connecting to your pod. So this is how you can access it, right? You can go to var www.html, type in ls, and all the same commands we did before, and you see you have direct access. But now you're accessing not a container that's running on your computer. You're accessing a container that's running on a Kubernetes. Okay, and now let's exit it and let's run another command in order to see what's going on. kubectl logs, paste in the ID, and let's say follow. And now we see the logs that supervisor is generating. And let's look at this very important message. As you see that it's not able to connect to port 80. It's not able to do so because it's a reserved port, and it just won't work. So we have to correct it. So let's go to PHP Storm. Let's go to nginxconf. And let's find the port. Okay, and here we're just gonna change this to 8080. Okay, and we're gonna redeploy the image. So now the image is being generated, and we're going to push an update. And again, as you see, it's very important to know how to connect to your workload, how to view logs of your workload, because it can be rather confusing. It's showing us green here, but there's an error, and that's not fine. So we will work on that as well. I'm going to show you how we can add a health check, but that will be later. So now let's wait until our new version is deployed, and we will run it right here. So now we have generated a new image. Let's deploy it. Let's just put version 5. Let's push this version 5 to container registry. The image was successfully pushed, so now let's go back to our workload. Let's hit actions, rolling update, and let's change the version to 0.0.5 right here. Let's update it, and now Google is going to deploy 2 new pods with the new image. So let's look out. For now, it's still unschedulable. I'm refreshing. So here you go. So it already deleted one of the old pods. It already generating new one. And now let me just copy this name, because while it's contained under status container creating, we're not going to be able to access it. But as soon as it hits status running, we can access it. So let's do that here. Let's say kubectl logs, hit the ID and follow. Okay, and here you go. So now there are no issues right here, and we will move on to the next step. We will expose our IP, so we would be able to connect it from the outside world. And now it's time to expose the IPs. So let's go back to Docker file and ensure that we are exposing proper IPs right here. So as you see, we are exposing 80, but it should be 8080. So in this case, we will update it right here. I'm gonna push out a new image, 006. And I'm going to push it out. So you always have to ensure that whenever you're exposing port here, this one is matching to the actual port you're using. And here in Jinx, you see that we are using this port 8080. So let me just go back here, rolling update. I'm going to push out version number 6. And now, as we know that we are exposing these both ports, we need to somehow link them, connect them with the Kubernetes. So we can do it the following way. As you see here, Google is suggesting us to create a service. So we will do it right now. As you see, it's already Google has already recreated the pod. So now let's press actions, press expose, and now we can create our own load balancer. So here we have few options. Let's examine service type first. We either have node port, so it would expose the IP right to the node. We don't want to do that. We can have cluster IP, or we can have a load balancer. My suggestion is to use load balancer, and we will use load balancer right now as well. So this is the port, this is outside port. This is the port that we will be accessing through the browser, that the front end will be accessing to backend APIs and so on. So the 80, this is outside, and target port, that's the port inside your Docker container. Let's just say 80 is going to access 8080 on a TCP, and you can choose UDP too, but that's for different cases. We will use TCP. And here, let's say 443, which is SSL HTTPS port, and here we're going to say 8443, the one that we used here. So make sure these two are matching, 8080, 8443. So this is matching. We chose the load balancer, and let's just say expose them. So now it is creating a new service right here. So we have a name for the service. We know the cluster, namespace, yeah, and this is internal IP. Currently it takes like 1 minute for it to assign a static outside IP. So we can just hit refresh, and there's still no IP. It's still working on it. Let's just go back to Workload because I like to oversee service from there. Let's access our workload, and as you see, endpoints. The endpoints part is still missing. It's still working on assigning the IP address for your workload. Here you go. The IP was successfully assigned on both ports. So let's do the following. Before we access it, we want to make sure that this IP is going to stick around. It's not going to get changed. So we would need to go to VPC network right here. I suggest to pin it as well. And let's open external IP addresses. So here in external IP addresses, we're going to see this IP address. And you see it says type ephemeral. It means that it can get changed, and if you're routing through DNS, it might get lost. So we want to make sure we are reserving this as a static IP. So here I'm going to call it frontend service IP, and put it in a node, frontend service IP. I'm going to reserve it. And now let me go back to workloads, access the frontend, and go back here to exposed services, and let's just open this one. And as you see, it's working successfully. So we are running our own Docker container successfully on a Google Kubernetes engine. Congratulations on that. We've done a big part here. At this step, our frontend is already working, and we're gonna look into statistics. First and foremost, we want to ensure that when Google Cloud says that it's running, it's actually running and it's not failing for any issues. In this case, we will add a health check. Health check is going to ensure that the workload is healthy. So let me explain you what it does. It's sending a request every few seconds to your pod, individual pod, right here and right here. And if it's getting success 200 status code, that means it's working. Therefore, it's gonna mark it as healthy, and it's gonna put a green check mark. However, if it's getting some exception error or it's not reaching it for whatever reason, it's gonna mark it as unhealthy, and you will know right away that it's failing. So let's add a health check. So we will add a health check in a YAML file. In Kubernetes, it's called readiness probe, and you can always look it up in documentation, such as Kubernetes readiness probe, and there are more probes such as liveliness and more. But the most important is a readiness probe. So let's implement it. We should go to edit, where we are editing our YAML file. Let's go down here, and let's find the place where it says name hello world. At this case, we wanna press in end of hello world, hit return or enter, and let's write a readiness probe. So I'm gonna say readiness probe. Now I'm gonna hit tab. It's gonna add a space, and here I'm gonna set the parameters. So first is gonna be failure threshold. So this is how many times Google must attempt to run this health check before marking it unhealthy. So as an example, it's sending request first time, it's getting 500, something's not working, it's sending it second time, it's getting again 500. And if on a third time it's getting again 500 error, that it's completely crashing and not working, it's gonna mark it as unhealthy. However, if on a third time your server responded with 200 successful message, it's not gonna mark it as unhealthy, and it's gonna continue marking it as a running successful node. So it's always good practice to leave this number on 3, or definitely not on 1. So now let's define our health check. So system, Google Cloud is going to be making HTTP request, and we will make this request on main path, we will put the port 8080. So here, since you're not making this request on a load balancer, you're actually making this health check on each pod. You have to address the port that your container is exposing. So in our case, it's 8080. And we will select the scheme. So in this case, scheme is going to be HTTP, but in production case scenario, you would say HTTPS, and here you would say 8443. So let's and actually in production case scenario, you would not even expose 80 because you only need to run it on HTTPS. So here, let me just expose it under HTTP, and we're gonna add a couple of more options. So you see, I hit enter, I go to the next line, and then you have to navigate on this to be on the same path with this location. So here I'm in the right location now, and we're gonna put initial delay seconds. So how it works? Whenever your application is deploying, let's say it just deployed, it needs time to do its own things. Let's say in supervisor, when it's a high memory, high CPU machine, it needs some time to deploy supervisor programs, tasks, and so on. So it's always a good practice to give your application a little bit of time to deploy before you're running health checks. So we are setting it for 30 seconds. That works for us. And now we can control how often Kubernetes is going to trigger that endpoint. In this case, we're setting this option period seconds 1, and it's going to run this health check every single second. And we're going to say success threshold to 1, and we will select timeout seconds to 1 as well. So success threshold is going to say how many consecutive times the health check has to respond with healthy in order for the system to mark it as healthy. In our case, if system says that it's good, we're going to mark it as running from the first time. But if you want to be more cautious, you could change it to 3. In this case, we will keep it at 1. And timeout seconds tells us after how many seconds this request is gonna time out and will be marked as unhealthy. In my mind, any response should be not more than 100 milliseconds or 200 milliseconds, ideally 50 milliseconds. Therefore, we can safely assume that if server is taking more than 1 second to respond, we can mark it as unhealthy. So this is gonna be it for readiness probe. And again, if you're unsure about any parameters or something, you can always copy readiness probe. You can go online, access this documentation, and take a look how it's done on the original website, and read if you are more curious about any option here. So now let's hit save. And as you see, the Kubernetes is going to create 2 more pods. And let's monitor them. So now if you see that it's currently under status container creating, and now you see it's running. However, now it's not green anymore. It has this warning sign. This means it's running, but it's not yet ready. And if we're gonna access it right now and look out for logs and follow right here, you see that it's actually healthy, but because we are giving it 30-second delay, it's not gonna mark it as successful. And as you see, it was just marked as successful, and Kubernetes is sending this health check right here, and we are responding with 200 response. Therefore, it's gonna turn from warning into green icon. Let's take a look. Right here, so here you go. This is healthy pod. This is how we set up a readiness probe. It's a very good practice because if your application is taking time or it's unhealthy, you do not want to send any requests to this pod because they will fail, and that's not what you want to do. Now, after we have launched our front-end workload and have ensured that everything is working fine here, I would like to show you how to monitor statistics such as CPU requests, memory requests, because that is very essential that you know how to administer your cluster and your workloads. So we will do the following. First of all, let's go to the cluster right here. So here you can see that your cluster, which is running on an autopilot mode, that's taking resources as you need, which is phenomenal. So here, as you see total CPUs, it's requesting 1 CPU in total and 2.93 gigabytes of memory. It's very logical because we are at our workload requesting, let's take a look, we are requesting 500, like half a core. This is why it's the cluster has created enough nodes, enough resources in order to support your workloads. Let's examine now how our workload is doing. So here, whenever you're opening your workload, it can consist of multiple pods. You can examine how much CPU was requested and how much CPU is used. So you see here that it's really not being used, and this time we used 0.02. And let's take a look on memory. So in memory it's 2.93 gigabytes, and we are using really not much. So it means really the container is extremely optimized. We are not running any extra tasks there. This is why these values are so low. So as a DevOps person, we can go ahead and optimize it and decrease the CPU and memory requests. So let's do that. Let's change the CPU limit to 300. Let's change request to 300, and now let's adjust the memory. So in this case, there is not much memory needed, so we're gonna change it to 800, and we will change to 400 right here. And again, you can change these values as you feel like, as you need to, but you need to understand that you have to look at overview, you have to look at stats right here, because, and also you have to look at the peak, because let's say if your business has peak hours and not peak hours, you must ensure that it is supporting, that these Kubernetes are supporting your workload. And now we're gonna, in next chapter, we're gonna talk about auto scaling, because that is how we will be able to support it. So now let's just examine how our resource requests have changed. As you see, Google is recreating our new pods. And by the way, as you see here, while they are being created, we have a flag here that there's a warning. And whenever you're overviewing your workloads, whether you have 1 or you have 100, it's very convenient, because you can see that here 1 of 2 updated replicas available. This is type of deployment. You have 2 pods that are requested, and there are 3 in total, because 1 is being killed and 2 are being recreated. So let's just open. Here you go. It's all green, and it's all great. So now you will see that requests have dropped, and you can also take a look at the statistics of each pod individually. So let's open it and let's see. Usually I give it a few minutes in order to load up more data, but we can already see that it's requesting 0.25 CPU and it's using much less than that. And here it's requesting 500 megabytes of memory, but using much less than that. And let me go back here to our workload. Let me go back here, and as you see, our front end is working extremely fast. I can refresh multiple times and it's working just fine. And let's examine our cluster. And as you see, the CPUs have dropped to 0.5 and 1 gigabyte. It's because we decreased the resource requests from our workloads. This way we were able to cut down on the server costs just by decreasing the requests. Again, that depends on each workload, whether it's backend API, so that's another decision to make. But now you know how to change resource requests on your workload. Let's examine how auto scaling is working. Why do we need it? Because each business, each corporation, each project has peak hours and off-peak hours. Just imagine there are 24 hours in one day, and you will have more users accessing your system at 9 a.m. or at 4 p.m. or at 3 p.m. And most likely you will have less users accessing your system at 2 a.m. and that's normal. This is why its traffic is dropping. It means you need less resources to support. Or if traffic is skyrocketing and you have more and more users accessing your dashboard, you want to ensure that your workload is scaling and is able to support all that traffic without any lag. And let me show you how we can achieve it in Kubernetes engine. So let's press workloads. Let's open your workflow. And now we want to set up a proper auto scaling. This is how we're going to do it. So let's press actions. Let's press on button auto scale. And now we can tell, now we have all the configurations. We can tell how many minimum pods do we want to run at the same time. So in this case, I'm going to say 3 because you know what, sometimes it's better to be safe than sorry. So I'm going to leave it at 3. So we will have 3 pods running at the same time. And now we can set up a maximum number of replicas. We can set it up to 220. And now the most important part, auto scaling metrics. This is how Kubernetes is going to decide whether to scale or not to scale your workload, because it needs to know parameters such as what is busy for you, at what point is it going to scale. And here it's pretty obvious. We're going to scale based on the CPU. So let's imagine we gave our container half a CPU, 0.5, or let's make it even more simple. We gave it 1 CPU. And let's imagine that you're getting more and more and more traffic. You're routing those web requests to your workload, and its CPU has increased already to 0.7. So what this means, at 0.6 or 7, it's already reaching the high, because when it reaches 0.9 or 0.95, most likely all of the requests will become slow, it can become unresponsive, and users will face really bad experience. This is why my suggestion would be to keep the target at 60 or 70%. In this case, I'm going to keep it at 60 for the CPU. Let me hit, please hit done. And now let's add another metric, because CPU is one metric. That's mainly needed for when you're computing things and so on. But what if you're using memory more than that? And let's just make an example. You gave your workload 10 gigabytes of memory and it's using 8 gigabytes of memory. It means that there's only 2 gigabytes left, and if it's going to use more and more and more, your applications become unresponsive, slow, and you will start hitting application errors. So we want to make sure that container is feeling all right. This is why I'm going to select add metric. I'm going to select memory right here, and I'm going to also select a target level 60%. So if you're using 10 gigabytes, if your workload is using 6 gigabytes of memory, it's gonna make another pod. Again, you can change this as you feel like. You can change it to 70% as well. That's totally fine. But you always have to monitor it, look out how your workload's performing, how about are the response times, and so on. So in this case, I'm keeping it 60-60, and that's it. And we can also add external or custom metrics. Just making this example, you have 1 million jobs in Redis queue that you need to process. You need to scale up your servers. So you would be able to add another metric which will tell you, you know what, I need to scale more servers because I want to keep my Redis queue at, let's say, 1,000 jobs at the same time. So this is just an idea, but right now we're not going to add it in. So 320, 60, 60, let's press update. And now, since we indicated a minimum amount of pods, system is gonna create one more pod. Let's examine. right here. And as you see here, Kubernetes is scheduling one more pod. You might ask, but you gave 20, maximum 20 pods, 20 replicas. Yes, but it's not seeing a need. Why? Because you see we have requested 0.5 CPU and 1 gigabyte. However, we are using far less than that. This is why it doesn't see a need. If it could, it would scale down to 1. But because we are requesting minimum 3 pods at the same time, it's acting this way. So it's working just fine. Let's hit a refresh. And now what's happening, because your cluster doesn't have enough CPU memory, it's adding more CPU memory right here for the cluster, and once it has those resources, only then it's gonna go in here and deploy an extra workload. So here you go, it added extra resources and now it's deploying a new workload. So Kubernetes has successfully deployed the third pod and they're all set here. Let's explore another very important topic when we think about Kubernetes, that is security. Those are environment files. In this chapter, we will do the following. We will create our own environment file, we will deploy it to Kubernetes, and we're gonna connect it with the workload. So let's take a look at this, this page, secrets and config maps. Let's open it right here, and we can see that Kubernetes already has some secrets and config maps. So we will do the following. First of all, my suggestion is when you make a project, let's say, you would keep multiple folders for your application, such as backend APIs, frontend, and so on. And you would keep one folder with your security files. And we will do the following. So I've created that folder, and make sure you're creating it as well. And right here, this is where we're gonna store them. So let's do the following. Press new. We will call the file environment credentials.json. So let's type it, env credentials.json. So in this file, we will define some configuration, such as key. We'll call it test application key, and we will say test and value. So this is just a simple config, so you can have idea how we're gonna get this config file onto the workload. So once we have it, let's open our terminal right here, and we will use the following command in order to apply it in the cluster. So let's type kubectl create secret, and we will use generic type because it has different types. We can also add SSL certificates here in order to safely keep them in a cluster. kubectl create secret generic, and we will call it env credentials, and we will say from file equals, and now you can set any name you want for this file. I'm gonna keep it the same as we have it, and here you have to say equals env credentials. So now it's gonna create a secret with this name, and it's gonna use the data from this file. So now let's hit it, and now you can see that it was successfully created right here. So let's go back to our secrets. Let's hit refresh, and you can see here that there's a new secret. It's called env credentials, and now we want to have a way to connect it to our workload. So now, since we added the environment credentials on our cluster level, let's open the workload, and now we will do this magic in our YAML file. So let's press edit, and let's scroll down where we have defined our application, our container. So first of all, whenever we are connecting another container, or in this case a config file, first of all we have to take this configuration file and link it with the whole workload, because you can have 5 containers inside that would use this config. In our case we have 1 container, but we still need to connect this config file to the workload, and then your container will be able to use this config file. So let's do the following. Identify first where we can do it. So to keep it simple, find the end. End is here where it says termination grace period second. So hit return, and now we can type and connect extra volume that we need. In Kubernetes, they're calling it volume. So that's whether that can be a storage volume, they can be different volume. In this case, that's going to be a config or a secret that we will be using. In our case, that's a secret. So let's type in volumes, and on the new line, put a minus. Again, it can be a little bit confusing that we are putting the minus and all that, but when you get used to it, you will be just fine. So let's call our config env credentials, and let's say here secret 2 dots, and in the new line we're gonna say default mode. So this is gonna be read-only mode, and we are saying so secret name is env credentials. So this name could be changed. However, it's very important that env credentials is staying the same as we defined it before. So now we have connected the environment credentials to this whole workload, to your whole deployment on the Kubernetes. So now let your container know that this secret file exists. So now let's scroll up here, and let's find this line, termination policy. So this is the end of your container's configuration file, and here we're gonna say very similar thing that we did before. I'm gonna say volume mounts. This is where we are mounting the volume. We're gonna put again a dot. I'm gonna say mount path, and here we're gonna say I want this file to be mounted in this directory, secrets and environment. And now I'm gonna go into new line and say name. We're gonna call it the same environment credentials as we defined it on the bottom, and I'm gonna say that this is read only true. And now let's hit save. So now you see right away Google is terminating 2 of the pods, creating already a new one, and scheduling 2 more. So let's hit refresh. Alright, so it has already created 1 of them. Let's copy the name. Let's go into our terminal. Let's clear this up, and I'm gonna say kubectl exits.t. Then you copy in the ID of your pod, and we will say sh. Okay, and now we have successfully connected to your pod. Now let's take a look if the secret file is accessible here. We will do the following. I'm gonna say cd secrets environment. So now we access this directory. Let's do ls, and you see there's the file that we connected. Let's do cat environment credentials, and here you go. You can access your environment credentials, and now it's up to your application how your application is gonna parse it. Whether it's a node app, it can take values from here, or we can insert direct environment file for your node application, or for PHP application we can just parse this and insert it in environment file. There's so many ways we can do it, but it's very important that you know how to connect environment or credentials or configuration file from cluster directly into your workload. What's great about it is that if you have a master environment or configuration file and you have 10 workloads, this file can be shared along all of your workloads. And whenever you need to update something, you're updating it securely in one file, and all of your workloads will know about this change.